This is the Unit 2 review for ENGR 101. The first problem here we have is a problem where you plug other functions into other functions. Shown the first one, we have f of g of 1, meaning that what is the function of f, where the given value is from the function g, given that x equals 1. And that's what this is asking us to solve. So it's kind of a function within a function with some given x value. And sometimes we're given different notation. So you can write it as f of g of x, or f o g of x. These are the same thing. And then if you plug in x, that means you're leaving it as a function. And if you plug in some value such as 1, then it should be left as we should get a constant as an answer. So first one, you always start with what's on the inside and go outward. So I have a function f of, so I'm looking at f, and it's x plus 2 over x. But what I'm supposed to put in is g of 1. So g of 1 is going to go in for this x and these x's here. So I'm going to have g of 1 plus 2 over g of 1. And then replace g of 1 with the function g of x, which is this function here, where each x is 1. So we have 1 minus 2 over 1 plus 2 plus 2, all divided by 1 minus 2, 1 plus 2. We simplify 1 minus 2 over 1 plus 2, it becomes negative 1/3, so it's going to equal negative 1/3 plus 2 over negative 1/3. Get a common denominator and combine the numbers in the numerator. It's going to get us a positive 5/6 over a negative 1/3. Let me simplify that. It's going to become 5/6 times negative 3, which will get us negative 5/2. Notice we got a constant here, so we know we did everything right. We left all the x's out. And then for the next one, it's the same thing, but we flip g and f. So instead of replacing each x with a g of 1 and f of x, we're doing the same thing with f of x, or f of 1 for the function g of x. So we're going to have f of 1 plus, minus 2 over f of 1 plus 2, which will equal 1 plus 2 over 1 minus 2 all over 1 plus 2 over 1 plus 2. So the 1 plus 2 over 1 simplifies to 3. So you have 3 minus 2 over 3 plus 2. And then that simplifies down to 1/5. So this next one, again, it's a different notation, but it just means the same thing as g of f of x. So when we do this one, we should get a function of x instead. So we're going to plug we're going to place each f of x in the x's for g of x. So we're going to get f of x minus 2 over f of x plus 2. Replace each f of x with x plus 2 over x. So x plus 2 over x minus 2 over x plus 2 over x plus 2. Get a common denominator for x in the numerator, or sorry, for 2 in the numerator and denominator. So it's x over x multiplied by x over x. You then are able to get x plus 2 minus 2x all over x plus 2 plus 2x all over x. You have an x in the denominator of each function here. So you're able to cancel out your x, and when we do that, we note that x cannot equal 0. And then when we continue, we're going to simplify the numerator and denominator further. We're going to get negative x plus 2 over 3x plus 2, where x cannot equal 0. So that is our function. Next thing is to find the domain for that. So we already know that x can equal 0, so the next thing we need to look is for the denominator. So where 3x plus 2 cannot equal 0, which implies x cannot equal negative 2/3. So for all given values of x cannot equal, and you must go in ascending order, so negative 2/3, comma, 0, close bracket. Right? So that is our first problem with functions. So, and really make sure list all unapplied restrictions as well. So that's why I list that x right there. X cannot equal 0. Right. Move on to the next problem. So we're going to find the vertex and axis of symmetry for a given parabola. So in order for us to do this, we must first write what is the standard equation for a parabola, which it is different, couple different ways you could go about it, but how you could write it. But they want you to write it as x minus h squared equals some constant we can say is b times y minus k. So hk is going to be your vertex. So whatever h and k happen to be from our given function will be our vertex, and our axis of symmetry will be x equals to h, assuming that it is a function of y. Since x is squared here, y is not squared, that means that y is going to be a function of x. So, all right. So first we got to manipulate our variables. So we're going to have to get all of the x's on one side and all the y's on one side. Seeing that we're probably going to have a binomial, we're going to have to move the constant with x as well. So we're going to have x squared plus 4x minus 3 equals negative 2y. So if x squared plus 4x minus 3 is easily factorable, then we don't have to worry about completing the square. But since it is not easily factorable, that means we must complete the square. So what completing the square means is we take half of the inside, so half of what b is in terms of ax squared plus bx plus c. Take half of b and then square it and then add it and then subtract it as a form of 1 in order for us to simplify it. So we take half of 4, which is 2, square 2, which is 4. So we're going to have x squared plus 4x plus 4 minus 4 minus 3. So right here is our form of 0. So you can add forms of 0 or multiply by forms of 1. And adding a form of 0 is another way where we can manipulate algebra and not affect the overall value of a function. So since we added a form of 0 here, we can then separate the plus 4 and the minus 4. And so we can factor out the x squared plus 4x plus 4, and then combine the minus 4 with the minus 3. So we have x squared plus 4x plus 4. And I'm going to move the minus 7 over to the other side, because then we'll have plus 7. So 7 minus 2y. This is now a factorable function on the left side. So then this becomes x plus 2 squared equals 7 minus 2i. All right, so we have half this so far. we have the x minus h portion. Now we need to get it into a form where we have y minus k. And then that must mean that, so 7 minus 2y should equal, factor out -2 here. So -2, move y out to the front, and then we have minus 7/2 y. So in this case, our b, or whatever our constant is -2. K is then negative 7/2, or I guess it's positive 7/2, and h is -2. So now that we have everything, we can then say hk, our vertex, is then -2, comma, 7/2, and our axis of symmetry, AOS, is x equals 2, -2. Because remember, x must equal h, because at the vertex, it begins the same process, it mirrors itself.